Hi everyone, welcome to my series. In this video, I want us to couple and climb to the ring of a non-homogeneous system of linear equations against the homogeneous one. Well, in a non-homogeneous system, we find three things, and that is a trivial solution, which is sometimes called exactly one solution or a single solution. We also find a no solution, whereas in a homogeneous one, we do not have no solution. All right. Now we're going to find the third one, which is an infinitely many solution. And here I'm calling it a non-trivial because it is a synonym of infinitely many solution. For in case they want to try and trick you in the exam. So I'm going to do this question by means of elemental row operations, which I'm going to assume now that you guys, you know how to do that. So I'm going to perform that into a row operations. Now, to do that, I'm gonna augment our matrix, and that is going to be 1, 2, 0, and then a 2, 5, and -1 there. We've got a 3, we've got a plus 5, and a squared minus a. You augment this to your constants, and that is a minus 2 plus 2a, and you've got a squared minus a. So I'm gonna operate on that and make it into, or maybe reduce it, so to say, into a row echelon form. And that is your R1, your R2, and your R3. It's a very basic idea here to say put your row in that space so that when you operate, you see your main goal. So your main goal here is going to be having the leading one, and below the leading one it must be zeros, which in this case must be 0, and this is already a 0, so it's fine for you. So you will keep your first row because it's already a 1 just right there. This is going to be 1, 2, 3, and a there. Now the last row is also fine, so keep it because it's already a 0 there. There's 0, -1, and then a squared minus a. You've got your a squared minus a here, and you want to get the second row. So how do you do that? You say that is -2 R1 plus the preceding row, which is R2. And if you do that, you really get 0, 1, and you get a minus 1. Be careful there. And you're also going to get a -2 just right here. Now I'm going to reduce it further and make that -1 in the third row in the second column, which is this one. It must be a 0 because above that, which is this one, it's called a leading one. So below the leading one, it must be 0. So the first two rows, I'm going to keep them, and they are fine. And that is 1, 0, 2, 1, 3, a minus 1, and a minus 2 there. I'm just going to operate on the last row. So the last row is just going to be the sum of these two rows, and that is R2 plus R3. If you add the last two rows, you get a 0, 0, and you get the a and the minus a, they undo each other. So you basically get a squared minus 1, and then here it's a beautiful quadratic expression, and that is a squared minus a minus 2. That's a beautiful quadratic expression there. So we want to answer the question now, which is the first one. They want us to find exactly one solution. So exactly one solution, it's the same as a trivial solution. Now we are going to conclude based on what we have in this matrix. Notice that we have this particular value here, or an entry, which is a squared minus 1. So if this entry is 0, it either means you are going to have no solution or infinitely many solution. So for exactly one solution, this entry must never be 0, because if it's 0, it overlaps to a no solution or infinitely many solution, depending on what you have just right there. So I'm going to say a squared minus 1, which is this entry here. This entry cannot be equals to 0. All right. And you'll see that from here, you just need to factorize that if you are able, and to say that is a minus 1 and a plus 1 is called a difference of two squares in high school arguments. Therefore, a cannot be equals to positive 1 or a cannot be equals to negative 1. Now, this is how you'll answer it. That is the condition. Now, number 2, they want for no solution. So for no solution, you are still going to observe it here from this matrix here. Now, for no solution, this portion must be 0, and this one must not be 0, because you're going to have a 0 is equal to, say, maybe 7, for argument's sake, or for a lack of a better word, let's put positive 7. So if you have 0 is equal to 7, that makes no sense under normal circumstances. So we can't have a 0 equaling to 7. So in a direct approach, we are basically saying this must be 0 and this can't be 0. All right. Now we say that is a squared, and then a minus 1, it must be 0, and a squared minus a minus 2 must not be 0, I mean to say. And from here, it's just the basic algebra, which we saw that this one gave us a beautiful answer of a is equals to a equals to plus or minus 1. And then this side, if you try to factorize it again, you would get a minus 2, a plus 1, I guess. So therefore, a here cannot be equals to negative 2, or a cannot be equals to negative 1. I want you to notice something. You are basically saying that a this side is a is equals to 1, or a is equals to negative 1. But here you are saying that a cannot be negative 1. So there is a bone of contention there, like you are confusing yourself. Or rather, we are confusing ourselves. So we are going to throw away negative 1, because we can't say it is negative 1 and subsequently say it can't be negative 1. So it can't. But for the benefit of the doubt, you can take negative 1 and put it here and see what you're going to get. Now, if you put a negative 1 here, you are going to get a 0. And then this side, if you put a negative 1, you get a 0, which is not true. So hence I'm like negative 1, it cannot be true for no solution. But let's get a 1, this positive 1 here, and substitute it in the equation. If you have a 1 here, you put it there, put a 1 here, and you get what? You get a 0. This side, if you put 1, a as 1, you get I guess it's negative 2. So this is true. 0 is equal to negative 2. It means the requirement for no solution. So I'm gonna say, well, my a is equals to positive 1. So this is fine, but negative 1 is not true. Let's check for negative 2 and really see what we're going to get. If you take negative 2 and put it here, what do you get? You get 2 squared minus 1, and that is really 3. Already it's out, because this portion must be 0 for no solution. So I'm going to throw away that negative 2, because it had to be 0, but it is giving me negative 3 in this entry. So therefore, that is out of the discussion. So I'm going to say now, therefore, a is equals to 1 only. That is the only one value there that satisfies the condition of a no solution. Now, the third one, which is infinitely many solution. Infinitely many solution. Infinitely many solution. This is really easy. You go and observe your matrix, the one which is in row echelon form, which is this one here. You say this portion right here, it must be 0, and this must be 0 as well. Think about it. If you have 0 is equal to 0, you will have no solutions based on number of solutions in system of equations. So I'm going to have a squared minus 1 is equal to 0, and the other one, which is a squared minus a minus 2, it must be 0 as well. So if you solve it, previously you saw it gave you a equals to plus or minus 1, and a was 2, or a was -1 when you try and solve that quadratic equation. Now we want to verify it because we have, it seems like we have 4 values, plus or minus and that. So, but just try to put in this way that a is equals to +1 or a -1. You just take 1 and then now you throw away that one because you can't really be repeating roots. So now I'm going to say or a is equals to +2. These two just right here. Well, I'm gonna verify these answers if they are true. I'm gonna take 1 and put it here. If I put 1 here, I'm gonna get 0, and here is -2. So 1 is out because it must be 0 is equal to 0 for infinitely many solutions. So I'm getting 0 is equal to -2, which is not true. Now I'm gonna take -1. If I put -1 as a here, I'm gonna get a 0 and I'm gonna get a 0 here. So -1 is true. And then if you take 2, remember we have 3 values of a, which is this 2 as well. So if you take 2 as a, you get a 3. Already it's out because it must be 0 is equal to 0. So the only value of a here, that is -1. So therefore, a is equals to -1 only. Thank you very much for watching. So the value of a here, it's -1. And then here, that is 1. And here is not -1 and 1. Thank you very much for watching. Please subscribe to the channel.